So as I have told you, the first week we discussed about the basics of AI, and the first week was introductory session. Okay. From from this week onwards, for 2 weeks, that means next 2 weeks, this week including next week, we'll complete module 1, where our focus will be the topic of search methods. Okay. Okay. So search methods, you can say, so from 4 to 9, these are all search methods. So what is our objective in studying these search methods? AI is already mature now. You have got lots of program available which can do the tasks. Then why read these techniques which are very fundamental? The answer is that just because these are fundamental concepts of AI, we need to understand them. In fact, at the end of the module, you will see that the search methods that we study here are basically the way human beings think or take decisions. Okay. So we'll start with something called a state space. We'll start with state space. Okay. So lesson 4 is state space search. So what is the meaning of state space? So write the date and the topic in your content page. Update your content page. That will help you map what is taught in the class. Okay. So before going to state space, suppose a question is asked, what are your options after graduating from here? What are the options after graduating from here? Okay, all the options that are available to you. So all the options will constitute the state space. But what is best for you will be the solution, right? What is best for you will be the solution. Also, then I am talking about only at the time of graduating, because say 10 years after graduating, your options may be different, your choice may be different. So I am talking about only at the time of graduating. You have say 4 or 5 options to choose from. Then all these options are called state space. And how you decide which one is best for you? Suppose you got a job through campus selection and also you clear gate. Should you go for higher studies? Should you continue doing the job, or should you go for MBA, whatever? Okay, so how you decide which one is the best for you? So that is known as search method. Okay, so now it is clear that search is intuitive to human beings, and therefore any intelligence which is artificially made must also have the search method inbuilt into it. Okay, so when this computer science guys, when they study search method, they study almost maybe 1 or 2 papers on this, the details of search methods. But we will focus, since your target is only exposure, we will focus on basic methods only of search methods. Okay, if you want to know, go into further details, you have NPTEL courses available. Okay. Then another extension to this search method is constant satisfaction problems. That means I told you what is the state space. These are the options that you have when you graduate. Okay, you search for finding a solution, but then suppose you find that gate is best for you. You don't want to go for a job, but then you have certain constraints. Okay, suppose you have some constraints that you need to join a job to earn, because maybe you have a dependent family. So that is known as constant satisfaction problem. So even though you have a better solution, so you settle for a lower solution because based on the constraints, that is actually the best one. Okay. So where does this search method stand under AI techniques? Okay. So what is an AI technique? What makes AI programming different from general computational paradigms? Okay. So when I say general computational paradigms, the problem that I have given you, search method, is basically known as, you have read in your third semester, is known as, what is the name of the topic? When you find the best solution among a set of given solutions, that is known as optimization. That is known as optimization, right? So maximize or minimize the objective subject to a set of constants. So that is known as optimization. Optimization is part of a field known as operations research. And when I say operations research, popularly you might have known, when somebody goes for MBA, they have options marketing, operations, etc. When I say operations, they actually mean this. Okay, operations research means optimizing. But in AI parlance, the way these are optimized, these optimization techniques are not same as the way as AI optimizes. Techniques are different. AI search techniques are different. That is how human beings do it. For example, when you search for a solution, you don't do a derivative, then equate to zero, find the maximum minimum. We don't do that. Okay, that is mathematically done in the field of optimization technique. Okay, or you use soft computing. Okay, where you generalize some swarm or generalize some, say, genetic algorithm, okay, to find your solution. Genetic algorithm is also considered part of AI technique. Okay, genetic algorithm, swarm optimization are also AI technique, but when I say optimization, it is hard optimization. That means mathematical optimization. So AI search methods came from production systems, a system of programming in which captures the essence of AI systems. Okay. So what is the difference between AI search and optimization? AI problems span a broad spectrum, and the only common thing among them is that they are hard. Okay. So the problems, the solution is not that obvious. You cannot. What is the requirement of an optimization problem? Mathematical optimization problem requirement कौन? What? Anyone? What is the requirement of a mathematical optimization problem? Mathematical optimization problem requirement कौन? कौन कहती है? Minimize or maximize objective subject to constraints, right? What is the requirement? The requirement is that you must have a cost function. So there is some function that you have to minimize or maximize. So you should have your objective in mathematical form. So that makes them simple. You can find a mathematical model of your problem. Okay. Whereas AI problems are hard. We cannot, human choices cannot be mathematically modeled. Okay. That's why AI problems are hard. Intelligence requires knowledge. AI technique is a method that uses knowledge and is represented to. The most important concept of AI techniques is that they are generalizations. They are generalizations, the very essence of how human beings make decisions. Generalization. Okay. It is understood by the people who provide it, easily modified for specific tasks. So, as I told you, what is a state space? Who can define state space? Anyone? What is a state space? Okay. So, what is a state space? Problem solving tasks can be formulated as a search in state space. So, we are searching in state space. The state space consists of all the states of the domain and a set of operators that change from one state to another. So if you are asked a 2-mark question, what is a state space? Your answer should be this or similar to this. The state space consists of all the states of a domain and a set of operators that change one state into another. The states can be thought of as nodes. Write the keywords. If you write the keywords, you concentrate. Right? If you don't, you will just like that. If you see, you'll forget. You'll fall asleep. Okay. So write down the keywords. Okay. So the states are nodes in a connected graph. Okay. So since you are all from electrical engineering background, so you have read machines. What else you have read? Machines, network theory, etc. Okay. By the time you are studying machines, network theory, computer science students are studying graph theory and all those concepts. So for them, these are obvious. For you, these are not obvious, but we will study them as you require them. Okay. So as the name says, connected graph means there are a set of nodes which are connected by lines or edges. Okay. I'll show you. So this can be a connected graph. This can be a connected graph. Okay. And there is a start node. Suppose you are 9th standard and there is a goal node. You are employed in ISRO or you crack DRDO exam. So that's your goal node. Okay. Start node, goal node. Now what are the in between what nodes you should follow? Which path you should follow? Okay. One path. Suppose there is a path. There is another path from it which says you only sleep. You don't read at all. So there is another one path, but that will take you another 40 years to reach your goal. Whereas if you are sincere, you may reach your goal in 4 years. So this is a connected graph which has some edges and you have got nodes. You don't see the path directly to your goal. Can you see how you will reach your goal of joining DRDO, ISRO or creating some organization? Can you see directly? You cannot see because you don't know the in-between nodes. Okay? Right? Okay. Next. So certain nodes are called goal nodes. The problem is said to be solved. So when we say this graph is solved, when you find a path from initial state to goal state. So you find a path, suppose, so this is your path, suppose there is a connection here and this is your path, right? You don't go through this, right? So this is your path from, so that you have that subject I taught to the other section, I think, universal human values. The final goal is happiness and prosperity. So what is the path you should take to reach there? So depending on the nodes you choose, accordingly the cost will be there. Okay. Suppose you choose a path where you are lazy, you are not doing anything in discipline, then it will take a long time. So you will reach your goal node, you will reach happiness and prosperity after a long time. Okay. So that is also a connected graph. That's why I told you AI techniques mimic human thought, unlike optimization, which is mathematical. Okay. So this course is part of, it is advanced competency course, we call this. It started with the 3rd semester optimization, 4th semester Python programming, 5th is AI. Then in 7th another course will be there. So these are something which you are learning other than your own discipline, right? Thus, the set of all possible configurations of the relevant objects is the space of the problem states, or also known as, write down this, problem space. Okay, so this whole thing is known as problem space, is known as a state space. So this is a state space. Common example used in this context is the 8 puzzle game. So the other section I told you first class in our lab, we inquired about the 8 puzzle game. As I told you, since we are electrical engineering background people, we don't know all this game playing thing. Okay. Right. So tomorrow, I think in the class I have lab, right? Tomorrow. A2 na? A1. Okay. So you will write about the 8 puzzle game and come. And in fact, whatever we will cover in today's class, we will do that practical in tomorrow's class. Okay. The other section A2 also you follow it. Okay. Okay. So 8 puzzle game. What is the state space? 9 factorial. How many of you are professional chess players? Professional means you know actual real chess. How many of you? One or two must be there, na? Chess players. Fine. So why I am talking about chess? Because chess is also something that is quite human, right? As I have understood, I am not a professional chess player, so I am an amateur chess player. So as I have understood, every such game you should know the start state first. If you choose the first move properly, then you can easily win the game. Is it correct? Chess players, right? Okay, so we'll study about that in the towards the end. All this, okay. Okay. So now we come to the formal description of a problem in state space. So these are computer science students understand this very well. So for us it is new. Okay. But we learn this from a control theory perspective. So as you study in this semester, we learn all these things from a control theory perspective, which they don't have. Okay. But as I have told you, AI is a multidisciplinary subject. Okay. No one has any, what you say, ownership over it. That this discipline is only belongs to AI. No. All disciplines have contributed to AI. Okay. State space. What is a state space? Define a state space that contains all possible configurations of the relevant objects, all possible configurations, right? For example, a chess player. So he cannot think of all possible configurations, but at least when he makes a move, he knows if I make this move, what other moves, how many, at least 8 or 10 moves the other person can make. Okay, so that is the state space of his thought. Initial states. Specify one or more states within that space as possible situations from which problem solving can start. Okay, so you choose a initial state. Then goal state. Specify one or more states that will be acceptable solution. Just write the names: state space, initial state, goal state, operators. For example, in chess, you move. You move your, what do you say? What is that called? Chess? Pawns. So what is the general name? Okay. Next. Okay. So next we come to graph. Okay. We don't have any background on graph, so we will have a quick definition of what is a graph, a formal definition of a graph. You know what is a graph? A graph G comprises a set of vertices and edges. Okay, so you have got vertices and edges. So this is actually a quick intro to graph theory. Quick intro to graph theory. If somebody wants to know more about AI and all this graph theory, you can join one course on discrete mathematics. Okay, that is offered now in NPTEL. You can know in detail about graphs. So a set of edges is a doubleton subset of V, that means vertices. It's very simple. It's a formal definition. That means you have got two vertices, right? Two vertices and one edge. Why it is doubleton? Because it starts from one vertex to another vertex. Okay, that's why it is a doubleton. A B element of the set of vertices, whereas both are not equal. It says that. We denote a graph by graph of vertices and edges, right? So given GB is a graph and AB element of the edges, then we say that the vertices A and B are adjacent and the edge AB joins them are adjacent edges like this. So these are adjacent edges. Okay, A and B adjacent edges. Okay, and so on. Okay, so that is what is a path. So these are formal definitions of some intuitive knowledge that we have. Path means from one vertex to some other vertex. So what you remember from this slide? Remember that in a graph, the nodes are also known as vertices. The line connecting them can be edges. For example, suppose in Google Map, okay, in any map. So all the locations Okay. Okay, path. Okay. Okay, listen. Difference between a directed graph. So what is a directed graph? That means a set of vertices where you have a direction. Okay, where you have a direction. That's a directed graph. What's a tree? A tree is a graph where there is no cycle. For example, so this is a cycle. Whereas in a tree there are no cycles. This is a tree. Okay, this is a tree. Okay. Whereas in a graph there are only closed cycles. Okay. So these are the examples of directed graphs, and this is an example of tree. Okay. Look here. Tree, directed graph. So what is a graph search? So it is obvious now. Graph search means searching through the graph, finding out a path from various vertices through the edges, right? So go through it. The problem of finding write down this line you write down. The problem of finding a sequence of actions to achieve a goal is called searching for paths in directed graphs. To solve the problem, we define the underlying search space and apply search algorithms. That is the objective of this module. Okay, search algorithms. So a state space definition in terms of graph. A state space is a graph VE where V is a set of nodes and E is a state of arcs directed from one node to another. Each node is a data structure. You have some basic background on data structure, right? What are the various data structures? Array, linked list, and I think your first year you have studied data structure, right? Yes, little bit of data structures, C and data structures. Okay, simple things. Okay, contains a state description plus other information such as parent of the node, operator that generates the code. Each arc is an instance of one or more of the operators. Each node has a set of successor nodes. For example, suppose one node is where you only sleep in your hostel, you don't study. Then what is the successor node? You go without a job. You are utterly frustrated, you go without a job. That's a successor node. Okay. So if you study hard, follow strict discipline, then you get a good job or you score well in competitive exams. That's a successor node. So every node has a successor node. A goal test predicate is applied to a state to determine if the stated node is a goal node. So we have a goal test. For example, you get selected through a campus interview. Now you apply a goal test that whether this is the right one for you. So how you do that? So that is completely dependent on you. How? But a test, you should apply a goal test. Each arc has a positive cost. So when you follow a path, there is a cost associated with it. Okay. A solution is a sequence of operators that is associated with a path from start node to the goal node. The cost of a solution is the sum of R costs. So cost of the solution is the sum of R costs. Okay. When I go to arc, suppose from here to Bhubaneswar, so you can directly go through this Redacol route, or you can go through the other one. Okay, the other side. Okay. Long back when this road was very bad, people used to go through that route. But the distance in this direction is 300 kilometers, there it will be 450 kilometers. So you decide how much cost in terms of time, in terms of costs. So each connective point is an arc, whereas each city or town can be a node. Okay. And kilometers can be the cost. Okay, this is very important. Evaluating. How to evaluate the search strategies. which path to follow from going from Sambalpur to Bhubaneswar? Should I go directly through this, or nowadays after Anugul you can take the Badkera route, or you can directly go through the Chodwa route? Okay, so which one you should follow? So every time you have got two paths, right? So how to evaluate? The first is completeness. First is you should choose a path that leads to Bhubaneswar. तमें कहबो मु भुवनेश्वर जीवी तो तमें धवलेश्वर रास्ता धर दो, obviously भुवनेश्वर पहुंच परिबनी. So it should be complete. Complete means the path you are choosing should lead to a goal. Time complexity. Time complexity, how long does it take? Okay, so you say that I will go to Raipur, from there I will go some other direction, then I will come to Bhubaneswar. Obviously, it will take 2 days, whereas you can reach there in 4 hours. Space complexity. So how much space you have used, how much path? Okay. Optimality. So is it an optimal path? Okay. Is it saving you the minimum cost? Okay. Or it is saving you the maximum cost? Okay. So every algorithm is compared with respect to this 4. So what are the parameters? First is branching factor. Okay, गोटे नोड रो केतरा डायरेक्शन जाई परियो. मु कहली आफ्टर यू सी जो तपोवन रेस्टोरेंट अछि ता परे परे यू कैन गो थ्रू द बाडकेरा पाथ और यू कैन गो डायरेक्टली थ्रू द धवलेश्वर पाथ. ओके, सो that is known as branching factor. How many branches you can make from a node? Minimal length, obviously the minimal length between here to the goal state. The minimal length is follow the river, but you cannot go through that, right? Then depth of the shallowest goal. Depth of the shallowest goal node in the search tree. Maximum depth M of the state space. Maximum depth माने होची sometimes you get frustrated. आउ केते पढले मु पढिया पडियोनी आउ केते पढिबी हैला माने केते आउ पढिबा सब बेले पढी त आस्ट 10th रु सरुनी केते पढिबा. So that is known as depth. Okay, and this depth has end. I am telling you, after some time you will see that there is nowhere else you need to go. Okay, if you have reached a particular point, you need not go anywhere. You are utterly bored. Okay, next, connectedness. Okay, you can have connected paths or disjoint paths. Okay, spaces. So it I am पढ़िबा in detail in tomorrow's class. Is known as Euclidean distance, Manhattan distance. Euclidean distance माने हमारा geometric distance, the minimum one. ता वो उतरे Euclidean distance होची straight, whereas Manhattan distance means like a city block. This one. Okay, we'll see that. Then reachable subspaces. So which subspaces you can reach? Okay, there are some spaces you cannot reach. Okay. Okay, so what is a graph search procedure? Listen, open, closed, very simple concept. Closed means you examine a node. For example, you travel regularly from Sambalpur to Bhubaneswar. But once you pass through that Badkara route, you now see that the road is completely damaged. Then you say that this is a closed node. You won't touch that again. Okay, open node means that you have not yet explored. Okay, those are open nodes. So if n is a goal node, exit successfully. So from start node to goal node, go through all this in detail. So as I have told you, for every PPT I am adding more of material, some more material extra, right? I told you for first week I have added some more. जो फर्स्ट वीक रे जो एक्स्ट्रा दिया इतला के केत जण देखते होडा वो खाली ओपन करछ रेज योर हैंड. मु गोटे मेसेज पठे ना गूगल क्लासरूम रे फॉर फर्स्ट वीक सम एक्स्ट्रा PPTs have been added from NPTEL and all those sources. How many of you have opened it? Just see open good. How many of you? Fine. खाली ओपन करियो हला सेति तो कर परियो मोबाइल रे हमें हम जानती बहुत व्यस्त लोग बट स्टिल ठीक है ओपन कर दो हैला. Okay. So these are all, you will feel sleepy if I go through this in detail, we'll solve it. Okay. So it simply says that there are two sets of nodes, open and closed. So the extra material for this week that I have given you, there you can see how a node is taken from closed to open and vice versa. Okay. So this week will be search methods. Okay, uninformed search. So which one? Reorder the list open according to what? What criteria? By some arbitrary scheme or according to some heuristic merit. Okay, by some heuristic merit. Now, ये जो course टा देखो ची IIT गुवाहाटी रा, the whole course complete book, e-book I have also uploaded. Okay, so there you will find detailed information regarding all this, and you can understand. It's very nicely it is written, so you can understand that. If you don't understand something, go through it. Okay. So what is a state space search? Summary. Go through it. So what is a state space search? Choose your problem and determine what constitutes a state. Okay, what constitutes a state? Your problem is getting a good job after graduating. So roaming around, what? Always roaming around, not studying, that is not a state. Okay, that is not part of your state space. Identify the start and goal states. Identify the moves. This applies. जो मैंने chase करोगे, they can easily relate. Okay? Identify the moves. Write a function that takes a state and applies all possible moves to the states to go to a next state. Okay? Neighboring states. State spaces are used to represent two kinds of problems. One is configuration problem to find the goal state. One is planning problem to find a path to the goal state. Okay? Or the sequence of move. Okay, so this is the 8 puzzle problem. Now this goal state is different. This can be different. We have discussed then also. You see here, you have, how many of you have played? It's for kids. Okay, 8 puzzle problem is for kids. Okay, then you have got Rubik cube, right? Rubik cube. So, Rubik's cube कौन है ना कौन से Rubik's cube. Okay, so that one. So these are all toy problems in AI. So you see the goal state is 1, 2, 3, 4, 5. In this case, this is the goal state, but goal state can be different. Okay, you can give any goal state. So what are the moves? So 8 puzzle problem is a 3x3 board with 8 tiles, each numbered 1 to 8 and 1 empty space. Okay, 1 empty space is there and 1 to 8 are there. The objective is to place the numbers to match the final. Okay, so you are given this, how easily, how quickly, how with minimum number of steps you achieve it. Okay. So this is a typical solution. I obtained it from this reference. This is the typical solution for the goal space. Which path you should follow? Okay. See here, we are not finding the solution here. Our topic today is state space. So this is the state space of the 8 puzzle problem. Okay, this is the state space. Now, which path you should follow? That different algorithms will give us. So in tomorrow's class, we will see some algorithms. Okay. So this completes the first class today, state space.